So in this video, we're going to be talking about blob storage systems and how they're designed to facilitate petabytes of data distributed across hundreds or thousands of servers. Blob storage systems are really critical to a lot of systems you'll see in interview questions, for example, the classic design Dropbox question. So understanding how these technologies work at a fundamental level is really important. So at its most basic level, a blob storage system consists of a set of servers, and we can send raw files such as images, videos, or raw data off to these nodes, and the way that these nodes store the data is in a format of buckets, where a bucket just holds a big pile of files and each file has its own name. The name or key is usually delimited with slashes so that we can organize files effectively, but really this is just a name. What's unique about blob storage systems in comparison to a regular file system such as you have on your computer is the fact that this bucket really is just a collection of objects, and they're not really structured or organized in any meaningful way, whereas a file system is a tree consisting of folders and files within those folders. Because of this loose organization, blob storage systems can scale really effectively, since all they have to worry about is just this name of the file. The key to scaling a blob storage system is ensuring that we can distribute all of the data stored in the system across an arbitrary number of nodes. So if we want to store petabytes of data, we're going to need hundreds or even thousands of nodes available in our cluster, and we need to make sure that our system can effectively distribute the load that we require across all of those servers. The primary way that this is done in blob storage systems is sharding. So the trick with sharding is to use the key or name of the file, in this case /a/b/c, and use that to deterministically figure out what node that data should be stored on. So when we're writing data into our blob storage system, we can use a hash function on this name, and the hash function will deterministically return a number, and /a/b/c will always map to that number. We can then perform a modulo on that number. So if we have, for example, 10 nodes in our system, we get 5, so we know to store this data on the 5th node in the cluster. So we write this data to the 5th node in the cluster, and then when we're going back to read the same data again, if we want to look up data under that specific key, we can simply use the hash function again, and we immediately know that the data is going to be stored on node 5. So we don't have to have any centralized location that knows the location of every object in our system, which means we can scale to an arbitrary number of files distributed across an arbitrary number of machines, because our client, in this case, is actually able to calculate where the data should be read and written to. This sharding approach has a lot of interesting impacts on the scale and throughput of our system. So if we have 10 terabytes of data and we want to store this on a blob storage cluster with 10 nodes, our hash function should have a random distribution of values, which means that this 10 terabytes of data should be randomly mapped to all of the 10 nodes equally. So each one of our nodes will have about 1 terabyte of data stored on it each. So if we needed to store 10 times as much data in our system, we could simply have 10 times as many nodes, and we'd have proportionally less data stored on each node. So this is how blob storage systems can handle a huge amount of data stored on them. But we also have to consider how fast we can write to and read from our system. So let's say we have 10 gigabytes of data every second that we want to write into our blob storage system. Again, if our hash function returns a random distribution, each write that a client is making will be sent only to one node for that write. So we're actually splitting all of our writes across all of these 10 nodes equally. So in this example, with 10 gigabits per second of throughput and 10 nodes, each node is handling 1 gigabit per second of throughput. And finally, for reading, we'll notice that we don't have any problems with having a very large cluster. We could have 1,000 nodes, but when we're reading a piece of data, as long as we know the key for that data, so if we say fetch a/b/c, we know the hash of that value, and we know exactly what node the data is stored on, so we have about the same overhead as a single node system in this case. This does fall apart, however, if we want to do list queries. So for example, if we want to list every object stored in our system, depending on the way our blob storage system is architected, we might have to go out to every single one of these nodes to see what data it has stored on it. So this is an important consideration when you're thinking about your query patterns of how you're going to access your blob storage system. Now, an interesting thing to note here is, for example, if we have 10 nodes, the likelihood of one server in a cluster of 10 nodes failing is actually 10 times higher than the likelihood of a single server failing. So when we start to deal with really large clusters like this, it becomes really important to integrate other forms of fault tolerance into the system. One easy way to do this is to simply have a replica of all of the data stored in our system. So our previous system had 10 nodes. We can now have another set of 10 nodes that are simply replicas of each of the other 10 nodes, and any data that we write to our system will be written to both of these nodes simultaneously. Likewise, when we're reading, we can actually distribute our reads across the primary node and its replica. So if we have 10 gigabits per second of reads and we have a primary node and one replica, we only have 5 gigabits per second per replica. Since both of these nodes have the same data stored on them, it doesn't really matter which node we read from, and we can load balance between them. In reality, modern blob storage systems use much more complex approaches involving parity that can ensure that we don't need twice as many servers that are just dedicated to fault tolerance. So this is a trade-off we have to think about when considering the size of our cluster and how much fault tolerance we really need. So hopefully this video gave you a good overview of how blob storage systems work and how they're architected to achieve such high scale. If you enjoyed this video, you can find more content like this on interviewpen.com. We have tons of more in-depth system design and data structures and algorithms content for any skill level, along with a full coding environment and an AI teaching assistant. You can also join our Discord, where we're always available to answer any questions you might have. If you or a friend wants to master the fundamentals of software engineering, check us out at interviewpen.com.